Hi guys, just a quick video over demonstrating how to calculate average atomic mass. This is in your note booklet and we're going to look at example number 1 to begin with. Example number 1 says that of all chlorine atoms, 75.771% are chlorine 35. That number 35 is an isotope and it relates to its mass of chlorine. So chlorine 35 atoms have a mass of 34.96885 AMU. All other chlorine atoms are chlorine 37, a different isotope, and these have a mass of 36.96590. I'm going to show you really quick how to calculate the average atomic mass for chlorine to begin with. So to calculate the average atomic mass, we are going to take the mass times the percentage for each of our isotopes. So chlorine 35 said that the mass, we said that the mass for chlorine 35 was 34.96885, and we're going to multiply that by the percentage of chlorine 35, but we need to write that percentage in a decimal. So the way that we do that is we say 0.75771, and we'll take this amount, this quantity here, and multiply it by our other isotope, add it to our other isotope. So we'll say plus our amount of chlorine 37, and the mass for chlorine 37 was 36.9650, again multiplied by the percentage of chlorine 37 that we have, which was given to us, we can calculate that. So if we have 100% of chlorine atoms and 75.77% of them are chlorine 35, we can easily calculate the rest, which would be of chlorine 37. So I'm just going to do that quick calculation, which is 100 minus 75.771, which gives me 24.229. And that's 24.229% of chlorine 37. I'll just make note of that. That's 37. So we'll do 36.9651, which is again the mass of chlorine 37 times its abundance, and again in a decimal form would be 0.24229, close parentheses. When we type that into our calculator, make sure that you're using parentheses so your calculator doesn't get the order of operations mixed up. I'm going to type in 34.96885 times 0.75771, close parentheses, plus 36.9650 times 0.24229, close parentheses. And that gives me the average atomic mass of chlorine. The average atomic mass of chlorine for all isotopes, that would be for chlorine 35 and for chlorine 37, I got 45249718. Let's be sure we go back and check for sig figs. So in our problem, we were given 5 sig figs for the percentage of chlorine 35. We were given 7 sig figs for the percentage, or for the mass of chlorine 35, and we were given 7 sig figs for the mass of chlorine 37. So we should make sure our answer has as many as the one with the fewest, which we said was 5. I'm going to round that off to 5 sig figs. That gives me 35.452. And this is a mass, so we're going to write grams as our unit. All right, that was for example number 1. Let's look at example number 2. And again, I'll just do that kind of quick math that I did for chlorine 35. I'll do that off to the side just like I did last time. But I'm going to erase this example, so hopefully that's clear enough for you all to see. I'm going to erase this example, and we'll look at example number 2. Example number 2 gives us that, it tells us that a certain element has two isotopes. So it doesn't give us the element, but that's not important. We don't need to know that. One isotope, which has an abundance of 72.15% and a mass of 84.9118 AMU. That's a mass unit there. The other has a mass of 86.9892 AMU. Let's calculate up our percentage for our second isotope here really fast. So if 100% would be our total, we'll take away what we know. We know 72.15%. When I take 100 minus 72.15, I get my second percentage, which would be 27.85%. Now, I said grams, I just remembered. I said grams on example 1. We really should have used AMU because those were the units that we were given. I'll try to do that here for the second one. So looking at example 2 here, our first isotope gives us a percentage and a mass. So let's go ahead and calculate, or begin writing our calculations. We know the mass of the first isotope is 84.9118, and that unit was AMU. And we're going to multiply that again, just like we did for our first example, by our percentage for the first isotope, which was 0.7215. Again, I just took that percentage and put it into a decimal, just as we always should when typing it into our calculator. I'm going to close parentheses, add. Let me erase the side work I had over here, but it was 27.85%. We're going to add that to the mass times the percentage of our second isotope. So the mass of our second isotope is 86.9092 AMU. And we will again multiply that by the percentage that we calculated, which was 0.2785. So again, just taking that percentage and turning it into a decimal. Alrighty, so we could type that into our calculator. It would be open parentheses 84.9118 times 0.7215 close parentheses plus open parentheses 86.9092 times 0.2785 close parentheses. That gives us our average atomic mass of this unknown isotope. And our average atomic mass was 85.4680759. Again, we never forget about sig figs. So looking at the numbers in our problem, we were given 4 sig figs for our first percentage there, 5 for our first mass, and 6 for our second mass. So we should always go with the fewest. We will go with then 4. The 6 becomes an 8, so we'll call this 85.47 AMU. Again, AMU was our unit for mass if we're talking about an atom. All right, very good. You should continue on to the next page and begin practicing those try it out problems that you have.